Earth systems.
The next set of PowerPoints are for the Earth systems objectives. Don't forget your quizzes tomorrow. There's like 40 questions. We started off today going through a couple of the answers here from, I think, the 2008 practice exam. So number one, it's location where a new crust is being created at a divergent boundary. Remember that that's letter C. I know it's difficult to see here, but that's where we have our mid-Atlantic ridge. And number two says the location where one tectonic plate is being forced beneath another, creating a volcanic arc. This is referring to the letter E, where we have the ring of fire. And number three, the intraplate location where hotspot volcanism is occurring. Intraplate means in the middle of a plate, not a plate boundary. And it's the answer is A, which is representing the Hawaiian Islands. So here we have our mid-Atlantic ridge. This is at a divergent boundary where our boundary plates are moving apart. And so we have hot magma that is coming up from within the earth, making this ridge. We have the ring of fire. Here you can see we have most of our volcanoes on Earth. And then also this is showing you a hot spot. So here we have a fixed location where magma is making its way up through the crustal plate. Again, this is intraplate, meaning within the plate. And so as the top portion of the plate is moving, we're going to see a string of islands like the Hawaiian Islands or Iceland. All right, for number one, it says to identify the greatest percentage of domestic water use in the United States. Flushing toilets is number one for domestic use. Just the number one use of fresh water by humans is agriculture, so irrigating our crops. Some ways that we can conserve water. We could use gray water. So remember, gray water is water that is used maybe in our sinks and even our bathtubs. Goes to a holding tank. You could see gray water tank here, and that water can be reused in our toilets and I guess possibly on our lawn. That's one way that we can conserve water. You could always do, if it's yellow, let it mellow. If it's brown, flush it down. So just conserving water and not flushing the toilet after each use. And then also look at other countries in Europe where they have two flushes, like a high flush and a low flush, in order to save water. So if you don't always need as much water for all bathroom uses. Number two, describe the soil in a tropical rainforest. So you can read it here. But remember that the soil is nutrient poor. So nutrient poor soil. Two reasons why the soil is nutrient poor is because of the amount of decomposition that's occurring. So at the bottom of a tropical rainforest, you have decomposers that are breaking down organic matter at a very fast rate. The plants and the trees, the vegetation is drawing up those nutrients, and all of the nutrients are found in the vegetation in a tropical rainforest. The second reason is due to the high amounts of precipitation. So it's going to leach out any of the minerals and nutrients out of the root zone where plants can reach. It's going to leach it down to the groundwater, and so that makes the soil nutrient poor. Remember that the order of the soil type in a tropical rainforest is an oxisol, and tropical rainforests are some of the most productive ecosystems on Earth. They have high biodiversity. Number three, identify elements that make up the Earth's crust. So you can see, even though there are 92 elements that are naturally found, only 8 of them are common. And 8 elements make up more than 98% of the Earth's crust. So the most common, starting with oxygen. The core and the mantle have iron, and the crust will be oxygen. The next slide is showing you a picture of the inner part of the Earth. So you can see we have the inner core, the outer core, the mantle, and the crust. Remember, the crust Then the upper mantle is considered the lithosphere. And a little bit deeper in the mantle, we have the asthenosphere. So we have the core, mantle, and crust. Number 4, volcanoes. 95% of the volcanoes on Earth are found at plate boundaries, so mostly at subduction zones. Subduction zones is when we have two crustal plates that are forcing against each other, and one plate's actually going to go underneath the other plate. The other 5% of the volcanoes are found at hot spots. Again, that's intraplate, so not at plate boundaries, but in the middle of a plate. Here you have a picture of how hot spots are formed. So you have a fixed plume of magma that comes up from within the earth. The top portion of the plate is going to move, therefore making a string of volcanic islands like the Hawaiian Islands. For the second part of that question, the effect of volcanic eruptions on Earth. Remember that when we have volcanoes erupting, that it's actually going to cause a cooling of the atmosphere. So we see that with the aerosol effect, and a volcanic eruption is going to cool the atmosphere. And you can see it's going to release some carbon dioxide, sulfur, specifically sulfate particles, hydrogen chloride, and the eruption is going to decrease the local temperature. Here we have most of our volcanoes occur along subduction zones. This was the slide I showed you when we talked about volcanoes in the first semester, first quarter. Most of our earthquakes occur along transform boundaries. It's when the plates are sliding past each other, like the San Andreas Fault. I don't think our textbook ever went over tsunamis, but just to give you a definition, because as I was going through the Barron's book, I did notice that they had some info about tsunamis. Just know it's a series of waves created when a body of water is displaced due to earthquakes. Many times tsunamis take place at subduction zones. So again, we're talking about those plate boundaries where you have two plates that are coming together. When one plate goes underneath the other plate, the lifting up of the top plate is going to displace water, and by doing that, it's going to make a large wave. And that wave is going to build and build and build until it gets to a shoreline, and it could potentially cause lots of damage to a lot of islands in the Pacific Ocean. All right, a fecal coliform test. So your next objective, number 5. Remember that fecal coliform tests are going to test for E. coli. E. coli are bacteria that live in the human and animal intestines. And so anytime that we have feces or fecal matter, a good indication of that fecal matter would be E. coli. You guys perform fecal coliform tests for your water quality testing, and anytime you show a positive for a fecal coliform test, you can assume that there is untreated sewage in that body of water. The next one I don't have a slide for, but it says identify the major biological source of dissolved oxygen in water. Anything that's going through photosynthesis. So algae, plants, you know that the process of photosynthesis, that they're using carbon dioxide and they're producing oxygen. So any phytoplankton, they're going to provide a body of water with most of its oxygen. Number 7 says to identify the primary cause of Earth's seasons. If you look at this picture right here, you can see that our Earth is on a 23.5 degree tilt. When the northern hemisphere is leaning away from the sun, it will be our wintertime in the north and the summertime in the south. And then in the summertime, when the northern hemisphere is leaning towards the sun, it will be our summertime and then the winter for the south. Also notice that we are actually closer in the northern hemisphere in our summertime. In the wintertime, we're closer to the sun. So in the northern hemisphere, when we're leaning away from the sun, it's our wintertime. We're actually closer to the sun than during our summertime. All right, number 7, identify the primary cause. Number 8, know the percentages of fresh and salt water. Looking at this pie chart, you can see that 97.5% of the water on Earth is salt water. Only 2.5% is fresh water. Out of that 2.5%, almost 2% is trapped in our ice caps and glaciers. And the rest of the water, less than 1%, is useful for us. So we can use this fresh water, the groundwater, and the surface water for our irrigation and drinking needs. Ways that we can desalinate water, we have 2 main ways. The first one is called distillation. Distillation is when we heat up salt water, we evaporate the water, and we leave the salt behind. The second way, which is more common, is called reverse osmosis. This is where we have pressure of some sort that is pushing salt water through a semi-permeable membrane. The membrane is permeable to water and impermeable to salt and leaves us with the fresh water. You should know some problems with desalination. Number 1, it's expensive. Number 2, it uses lots of energy. And number 3, we have to dispose of the salt someplace. So many times it's just thrown back into the estuary or the ocean, and it can throw off the salinity of an estuary. Soil. Don't forget your main components of soil: 45% minerals, 5% organic matter, 25% water, 25% air. Don't forget your soil horizons. So we have our O horizon. O stands for organic material. We have our A. This is where we have organic matter. Our E, heavily leached. Our B is where we have our minerals. So it's because of our clay there that we have lots of minerals and nutrients that gather in that layer. C, weathered rock, and then we have our solid bedrock, our parent rock. Okay, for our number 9. Make sure you remember our 3 soil particles. We have sand, silt, and clay. Sand is the largest, silt is in the middle, and clay is the smallest. Remember that gravel is not considered one of the plant or the soil particles because it has no benefits for plants. There's nothing beneficial about gravel. Your clay, like I said, is the smallest soil particle. It's so small that you would need to use a microscope in order to see clay. Clay has a negative charge, so it's going to adhere to positively charged minerals. And again, clay is found in the B horizon. Also, clay has the largest surface area. Be able to use a soil triangle. Some years they'll have one as a multiple choice question. Just really important to make sure that you line up all 3 percentages, that you don't just try and line up 2 and make a mistake. So important to do all 3. And then in this table here, you can see the soil texture type that is the most ideal for agriculture. That's loam. So you can see that loam has good aeration, drainage, mineral holding capacity is medium, water holding capacity and workability. When we have soil that's sandy, because of the large particles, they allow a lot of water to kind of wash away those minerals. There's good aeration. but it doesn't hold nutrients very well. For clay, you should think of clay as being very clumpy, so there's poor aeration, poor drainage. Clay soil gets waterlogged. It's able to hold lots of nutrients and minerals, again, because clay has that negative charge. High water holding capacity, and it's difficult to move or to till around. Also, don't forget that humus is broken down organic matter. Forgot to talk about humus, not hummus. For number 10, I don't have pictures for these, but I can just quickly give you the definitions. Synergism is when the combined effect is greater than each individual effect. If you remember from your textbook, it said 1 + 1 = 3. This a lot of times is referring to drug interactions. Antagonism is when we have opposing action of substances. Again, we're talking about pharmacology. This goes along with toxicity and dose response. It can also be used in ecology where one organism inhibits the growth of another organism for antagonism. Homeostasis is when something is going to maintain a stable balance. So your body, and I've said this, has a homeostatic temperature. You're going to keep the same temperature, hopefully around 98.6 degrees. You should link or think in your mind, homeostasis is kind of linked with a negative feedback mechanism. Commensalism, which we already did, one organism benefits, the other one's unharmed. Bioaccumulation, we already did. It's when an organism is going to accumulate a substance in its cells compared to biomagnification, specifically about the food chain. And then albedo, the amount of light reflected. Remember that a perfectly white surface will have an albedo of closer to 1. And a dark surface will have an albedo of closest to 0. All right, eutrophication for number 11. If you look at this picture here, you can see some sources of cultural eutrophication. That's eutrophication, what we've talked about. But eutrophication is the addition of plant nutrients to a body of water. So you should think phosphate and nitrates to a body of water. So you can see right here, untreated sewage, so nitrates and phosphates from untreated sewage into a body of water. Even treated sewage, so it's saying that it only went through primary and secondary treatment. So nitrogen oxides in the air. Really, you should think runoff from farms. You can see feedlots. So the addition of nitrates and phosphates to a body of water, this causes algae to bloom. When algae bloom, they are going to be rapidly decomposed by decomposers using up the oxygen in the water and making the water hypoxic. This in turn kills fish because there's not enough dissolved oxygen in the water. We looked at cases of eutrophication in the Mississippi River, and we talked about the dead zone at the Mississippi Delta. So right as the water is letting out into the Gulf of Mexico, every single year, around between spring and summer, we have some eutrophication there, and it's called the dead zone because all the nitrates and phosphates make their way down through the river and then emptying out into that Gulf of Mexico, making just water columns with no fish, completely dead organisms if they can't swim away, or just no fish at all because the water is so hypoxic. All right, layers of our Earth. So we did the other layers of the Earth. We know the inner part, we're going to have the core, and then the mantle, and then the crust. The asthenosphere is part of the mantle. The crust is part of the lithosphere. And from there on out, we have our troposphere. Troposphere is where we're located. So this is where we have our wind and our weather. We have our stratosphere, which is really important because this is where we have our ozone layer. There's no turbulence, so planes fly there. Mesosphere, the coldest of the layers. And the thermosphere, steady rising temperatures. And this is where our satellites are located. And then if we were to include the exosphere, it's the outermost and it converges with space. All right, so your Coriolis effect. This is the definition, a reflective force that arises from the rotation of the Earth. Note that our Earth is going to rotate from west to east. And this picture right here that we're looking at is if we're looking up at the South Pole. So if we're underneath the Earth looking at the South Pole, and we're rotating from west to east. And you can see here that the ball, as this merry-go-round thing is pulled in one direction, is actually going to curve to the left. And so due to land masses, a lot of the oceanic patterns we see are going, or currents are going in a counterclockwise direction in the southern hemisphere. In the northern hemisphere, they're moving in a clockwise direction. So it's just a reflective force because of the Earth's rotation from west to east. Here you can see the patterns. This is of our surface winds. Again, we're moving in a clockwise direction in the northern hemisphere, counter in the southern. Again, just showing you the movement. We're going counterclockwise in the southern hemisphere, more of a clockwise direction in the northern hemisphere. All right, BOD and DO. Your BOD stands for biological oxygen demand or biochemical oxygen demand, interchangeable. And it is defined as the amount of dissolved oxygen needed by aerobic organisms in a body of water to break down organic material. So it's the amount of oxygen needed by organisms breaking down organic stuff. The DO, dissolved oxygen. And you can see from this graph, you've seen this before, when the BOD is high, the DO is low. And so this could be, it says downstream from a sewage spill. So again, this goes along with eutrophication. As the biological oxygen demand increases, the DO, the amount of dissolved oxygen, decreases. And as you get further away from that sewage spill, the dissolved oxygen is going to increase again. So these are inversely related. And remember, if a body of water is lacking dissolved oxygen, as I said 2 seconds ago, it's called hypoxic. All right, just to throw in some of your winds here. You can see we have our prevailing winds, which we talked about in the beginning of the year. We have our trade winds from 0 to 30 degrees latitude. So we have our northeast and southeast. We have our westerlies from 30 to 60. They're moving into the west direction. And then our polar easterlies. And that relates to El Niño, because here we have what happens during an El Niño. Again, it's El Niño Southern Oscillation, an ENSO, El Niño for short. And remember that an El Niño takes place every 3 to 7 years in December. So it was named after Christ's child. You can think around Christmas time. And what happens during an El Niño is we see the air pressure drop, which reduces the trade winds. So when the trade winds stop or they weaken, we have warmer than normal water off the coast of South America right here. And so we see less upwelling. Upwelling is really important for the fish here because upwelling is going to bring nutrients from deep within the ocean and kind of mix it around and bring it to the top so fish are able to survive. So we see a decrease in upwelling, which means that we have less fish, and we said that we see an economical impact on the fishing industry off the coast of South America. This is what we see throughout the world. So we see these different weather events taking place. Some areas we see warmer winters, cooler winters, more precipitation. But for us in Florida, we see more winter storms. And just to remind you, a La Nina, which isn't on here, but a La Nina is basically the opposite of an El Nino. It's when we have unusually cooler temperatures off the coast of South America. And it's not as well understood, but many times we see a La Nina follow an El Nino. And that is your last slide for Earth systems.